Hi there, and welcome to another ARRI Tech Talk. Today we're going to talk about the HDE workflow for the new Alexa 35 cameras. My name is Oliver Temmler, and I'm the product manager for networked camera systems here in ARRI Munich. So before we dive into the topic, let's first get behind HDE, or let's get to understand HDE a little bit. HDE stands for high density encoding. It's a lossless variable bitrate encoding that can reduce the footprint of an ARRI RAW file by up to 40–50%. When you decode that back into an uncompressed ARRI RAW stream, you get a bit identical result. So the images are as good as directly from the camera. Codex originally created HDE to support Alexa 65 projects, which created a huge amount of data that often required additional hardware to be brought in just to keep everything at flow. Now, the first time HDE was used was on an Alexa 65 project called Spider-Man Far From Home, where the amount of data then finally was manageable because it was reduced to almost 50% the size. Today, HDE can be found in almost every production, feature film or television, no matter if it's a 65, a large format, or a Super 35 ARRI camera like the Alexa Mini. HDE lowers the storage costs, shortens the transfer times, and speeds up the workflows, which translates to direct savings in time and money. To ensure that ARRI RAW and HDE will always remain accessible, ARRI and Codex, we both published SMPTE RDD docs, registered disclosure documents, which explain exactly how the bit streams are encoded in these files. Let's talk about another few definitions. HDE, I just explained, is a lossless encoding technique specifically created for Bayer pattern images. MXF, something new that we've started to record with the Mini LF and now also use in the Alexa 35, stands for Material Exchange Format. MXF basically is a container that keeps several tracks of data for video, audio, and metadata. ARRI was the original file extension we used to store single-frame ARRI RAW data. ARX is the file format extension Codex used to store single-file HDE encoded ARRI RAW data. These are basically all the formats you need to know about and understand for the next slides when I'm talking about this. Now, let's look at the workflows as they are right now for, let's say, an Alexa Mini LF, and the workflow how it is for an Alexa 35. Codex offers a free software. It's called the Codex Device Manager, and that sits up in the menu bar. And Device Manager basically is just a front end for the Codex virtual file system. So when I insert a drive into a dock that contains Mini LF footage and that we can now see shows up on our desktop, and the virtual file system that runs behind Device Manager automatically created a second volume, a virtual volume, that contains ARX files, so HDE encoded ARRI RAW files. This can be enabled with a simple option in the Device Manager's preferences. You just say, for ARRI RAW content, I want HDE. So once you insert a drive, it shows up as the original, so you can access the original, or as the virtual HDE volume. Now, let's take a look at an Alexa 35 drive. So here's a 2 terabyte drive. Doesn't matter if it's a 1 or 2 terabyte, really. The 2 terabyte drive, if I insert that now, will only come up as the original ARRI raw recording. There's no HDE content created. The reason for that is how the MXF file is put together. Alexa 35 still captures MXF files like the Alexa Mini LF, but the images have more bit depth and a heap of additional metadata that required that we somehow reorganize the structure in the MXF files. So we could reduce redundancies and optimize the file I/O through our SDK that's used to process the files. So Alexa 35 ARRI raw MXF files therefore have a different structure from the Mini LF MXF files. The new reveal color science that's been created for the Alexa 35 was designed to take full advantage of that new MXF format. Single frame ARRI raw and ARRI raw files, or also HDE encoded RX files, they are only supported for legacy cameras or for cameras that came before the Alexa 35. Since Codex Device Manager at the moment can only create ARX files, so single frame sequences, they cannot be processed in the new SDK. And for that reason, we created an alternative. We licensed the HDE encoder from Codex and built our own tool, which is an easy-to-use alternative to encode ARRI raw uncompressed Alexa 35 to HDE MXF files, which can be processed in the new SDK. Let me demonstrate you what it looks like. So the new tool is called the ARRI raw HDE transcoder. The main window gives you the selection of a source directory, a target or destination directory, a job name, which is automatically created. You have the option to watch a folder, which I'm going to go into later, and to create an XX hash, which is an ASC MHL hash file for the HDE file it generates. I'll also show that in a minute. So with ARRI raw HDE transcoder, I pick a source directory, which would be my camera magazine. I have a destination, which is one of these 2 little drives I have sitting on top of this. So let's take that one. And then I just add the job. And you can see that the job just started. It has that name with date and time and the real. You can see the source and the destination path. It tells you that it's creating a hash, that it's currently encoding clip 1 of 9, and this is the progress of the current clip. The little X over here would cancel the job if I click that. So if I look at my target, then you can see those files popping up over here and here. You can see the original files. So 9 gigabyte encoded versus 16 gigabytes ARRI raw. So not quite 2 to 1, but it's a variable bitrate encoding. That means it depends on the content that's visible in there. If there's more areas with the same color, without structure, the encoding is going to work better. So there are different options how you can use the HDE transcoder. Now, one is you can basically use it to directly offload from the Alexa 35 drive to a target drive. Then you have an HDE output, and you can use it down the line. It's basically, that's the same approach that we had for Mini LF MXF files that you would encode through the device manager. You just didn't select source volume and target volume. It was more or less of a drag and drop operation, or actually you would go through an offload manager and tell the offload manager, this is my destination, this is my target drive. The second option you have is, because ARRI raw HDE transcoder will take any input you are not limited to taking the codecs drive. You could also first generate uncompressed copy, an identical copy of the magazine onto your first destination drive, and then do the HDE transcoding from there. The difference between the two is I'm basically copying the encoded data that's reduced in footprint to the target drive, whereas on the other hand, I'm copying all the data from the drive to a target. The benefit of doing it first with an offload manager is that I can create a checksum from the original drive and from my target drive, so I know that I have an identical copy of the drive on my target. If I do a transcode directly from the drive, it's not the same file anymore, and therefore it's not possible to do a comparison of the source directory and the target directory. So you will need to keep a hold of your original drive until the footage is cleared from post-production. However, it's been the very same all the time with Device Manager. So on Device Manager, you had the same thing. The HDE files were only generated from the original ARRI RAW at the time you copied them over. So your copy to the destination never was the original ARRI RAW footage. It was always a transcoded result. So essentially, nothing changes. The security, the safety is still the same. HDE encoding is really rock solid. So you get very good results. You never get really an error. And if there's an error during encoding, the encoder typically hicks up and tells you, hey, I couldn't read the ARRI RAW file for some reason. So safety-wise, it's the same. To be super safe, you first want to do your offload with a tool that allows a checksum comparison, and then from your target destination, do your encoding in your onward copies. To combine the two possibilities, what you can do is you can create an offload and use the watch folder functionality of ARRI RAW HDE transcoder to start transcoding to HDE as you do the offload. So let me show you how that works. So here we have the ARRI RAW HDE and a transcoder, and instead of pointing it to the original mag, I'm going to point it to the destination folder of my offload tool. My target, again, is going to be on a different drive, HDE output, and I'm going to enable watch source and add the job. So now it's just idling, and it's waiting for files to pop in. So in Offload Manager, I take my drive as the original, and my destination is going to be day 2 on La Silla numero 1, and do the offload. So and as this offload is now running, right, I'm copying the files. Transcoder also starts to process the files. So if I look at the drives directly, you can see as the files come in here, transcoder is already starting the work. So what's the benefit of using that option? Of course, you first do an offload of the original file in the original format. So you have the possibility to do a checksum comparison and be absolutely certain that the content on your target is identical to the content on the drive. And then you do a transcode that already starts as you're copying files over, so you can save a lot of time. So it's definitely a good option to use. Finally, I just remembered I wanted to show you what the MHL file is about. The ASC MHL file contains the description of the file that you copied, so you can see the size, you can see the path where it's written, and it gives you an XX hash 64. So a hash file, simple like a checksum that tells you if the data is still in its original form or if anything has been modified. So HDE transcoder generates this MHL file, which then contains a list of all the output files in there. So for every consecutive copy, every copy that's made from these HDE files, you can make a checksum comparison, an X-hash comparison, and you can see if anything down the line was altered, if a file was corrupted or something like that. So that's the use of that. So, and that's really it. So thank you very much for your attention, and maybe see you next time. Bye.